And now for something completely different, a wood box with knobs. So I'm taking a bit of a detour on the rebuild of the Grunau. It's still in the back there, you can just kind of see it. While I'm waiting for some paint to arrive for the front, I thought I'd take a look at another thing that I brought up for a rebuild. I actually have more than one of these little guys. So this is a Pilotuner. This is basically an FM receiver. It has no audio output or anything like that. This unit was intended to be hooked up to a standard AM radio, or even a radio with the early FM band, because these actually use the modern 88 to 108 megahertz frequency band, whereas early FM was a lot lower than that, and they scrapped it. I want to say television and a lot of the channels wound up being used for TV, so they had to bump things around. Unfortunately, I mean, a whole bunch of brand new AM/FM radios were rendered useless on the FM band because of that. But with these little guys, you get, oh, how many tubes is this? 1, 2, 3, 4. It's a 5-tube super heterodyne system. There is no rectifier tube, though. The Pilotuners use a Selenium rectifier on the underside of the chassis, tucked up in there. But these are transformer powered, so they're not series strung hot chassis style, which is kind of neat. I do actually already have the back out of this and the screws removed. The back actually has the hookup instructions, the basic ones at least, for this. So we have that. Now, this radio does have a built-in antenna, although the instructions allow you to use like a 4-foot length of wire off of one of these terminals, or even an FM dipole type antenna. But the built-in one is actually just a capacitor coupled to one of the AC line wires. So it's a lot of people have found out that trying to use this in conjunction with a non-transformer powered set will result in a lot of hum unless you use like an isolation transformer. So it's probably a good idea. The capacitor that's in there is just a regular mica. I'll probably replace that with a safety, like it's going to be a Y type because it's not across both lines. It's just from one of them to a line. So yeah. Either way, I thought it'd be a lot of fun to use this because I can use this in conjunction with my Lafayette AM transmitter that I have to broadcast common FM to my radios, which is pretty cool. Or you can just hook this up to a standard amplifier. Now, the only caveat is this is mono FM. These don't have stereo demultiplexing. Whatever. You can't pick up stereo. You can pick up stereo broadcasts, but they're not going to be split in the left and right channel. You only get one, and they're combined. So I'm told these seem to pick up stations pretty well, even with a short length of wire, or even with the built-in one. And I think these are just kind of neat. So hopefully I'll be able to do all this in one video. I don't want to spend a lot of time on it. The cabinet and all that I'll do later. The other thing I've heard about these is these knobs on the front here are often missing because these have the ship's wheel on them are the same as the ones used on the Pilot TV37 television set. It's got like a 3-inch CRT, kind of cool, very early post-war set. So let's pull the chassis out and take a look on the inside. So I've already done a little bit of pre-cleaning. I got most of the tubes wiped off, and I went over the chassis and the sockets and everything with a little bit of denatured alcohol to try and remove most of the grime. There is some discoloration. I don't know whether I'm going to bother to really try using like my polishing compound to clean it up all that much, because it's just going to have a back put on it, so you're not going to see any of it. But I got this really cute little power transformer up here in the top right corner. It's got a number 47 dial lamp. I may or may not replace that with an LED one. I only have a few left. I think I'll save those for the bigger consoles like my RCA 811 and 813Ks. But all the tubes seem to have been replaced at the same time. They are all fairly new RCAs, and they all have this neat little replacement tag on them, which shows they were replaced on November 1st of 1949. About 2 years after this unit was built. These came out in 47? But once they started making radios with the modern FM band, I suppose the sales probably dropped off and people started buying sets that could use it. Now I went ahead and I replaced, there's supposed to be these wire links right here between terminals 1 and 2 and 3 and 4 if you're using the built-in antenna. If you're not, you're supposed to remove this link and then you hook up like a 4-foot length of wire to, I think it's terminal 1, and then that gets sent out, something along those lines. It looks like, from what I can tell, this wire is actually set up a loop, and it's used, not like a tickler, I think, but just a like an air core transformer onto the first part of the tuning capacitor here. So that's your front end right there. And now, interestingly, I thought for a moment that these tubes here ought to have shields because they have these raised up sockets. I checked online, no, they don't have any shields, so it's pretty typical. And then we take a look at the underside. Try and do this gently. I don't want to damage the wonderful graphics on the front of this thing. Alright, there we go. You can see over here we have our Selenium rectifier. This can and the clamp are original. This is a 3 segments. You get two 40 microfarads at 150 volts and then a 20 microfarad that I believe is also at, 150 volts. That one goes off to this tube here. And then crammed up here in this spot are the power switch, which not only activates or provides the primary winding with continuity, but it also switches in and out of the audio path. So the idea with these was that if you had like a phonograph hooked up to your radio through its input terminals, you would disconnect the phonograph, this would go to those auxiliary input terminals, and then you had a second set of terminals on here to hook the phonograph back up to. And with the unit off, it reconnects the phonograph circuit, so you can use that, but then when you switch the unit on, it connects the FM tuner in circuit and disables the phonograph, so kind of handy. The instructions for working with a set that does not have phonograph terminals basically amounts to call a service technician, you're too stupid to do this yourself. That was kind of funny, because they actually tell you to read the manual, and the manual basically says you can't do this at home. Fairly good sized power resistor here. This is actually supposed to go between the two 40 microfarad sections, which it does. This red wire here travels back. I have powered this up earlier on my Variac. From what I've found, the Selenium rectifier is either bad or I have a fairly good amount of leakage somewhere in a capacitor, because the output is supposed to be 125 volts DC, and I'm getting a max of about 48. So I can't even get decent reception. I can hear like a blip occasionally on the audio output, but it's nothing usable. Not a whole lot of paper capacitors there. This 0.05 up here. There is another electrolytic, a 2 microfarad 50 volt right here. And there are a few well, actually these are Sprague ceramics. These are probably okay. I might leave them alone. And what else? Oh yeah, there's one line bypass capacitor, this great big mica mold block right here that's squished in between the power switch and all of that. That's going to be a lot of fun to get that out of there. And then you also have two Radiofrequency Chokes. These are actually coming in on the power leads, so these do have 125 volts on them. Gotta be careful around that. My plan with this, to try and replace this can and all that associated parts, is first of all, I need to replace the Selenium rectifier. It's a failure point. It's probably no good considering how much voltage I'm losing. This can isn't getting very warm at all, so I don't think that's where our trouble lies. And I'm going to replace it with a 1N4007 anyway, with a dropping resistor, once I figure out how much current this is supposed to draw. And I'll only know that once I replace the capacitors and actually bring it up slowly on the Variac and see what the tubes are pulling once the voltage is actually up there, because at no load, that's no good way to calculate it. The other problem was, where on earth are we going to put these three capacitors? Because they take up a lot of space, and I've seen some other restorations, and they just wind up going all over the place under here. And my idea is, this can is held in place with a clamp here. Can is grounded, common negative. Let's see if we can see here. The clamp is simply riveted in place to the chassis. So my thought process is, we drill that rivet out. It's underneath the power transformer, but the power transformer has enough clearance underneath it that I think the head of a 632 screw ought to be able to fit. So we unscrew the transformer, lift it up a little bit, stick the screw in there, and I'll mount a terminal strip to this point for the new capacitors. We'll have a terminal strip mounted to this number 6 hole for the diode and the dropping resistor, and then everything else should work out pretty easily. Getting in here and getting these out won't be fun, but I'll do those before I do the electrolytics. And yeah, hopefully that should all work out. Okay, before we go on to replacing the main electrolytic here and the selenium rectifier, I did do some work, and I wanted to point out a few things. So all the major film paper caps have been replaced with film on the side of the chassis here. This electrolytic right here is actually replacing the 20 microfarad 150 volt from this can. This orange wire right here actually goes to that lug. I disconnected it, and it simply ties, I believe it's a cathode of this tube here. I used this terminal strip, which had a blank center negative tied to that. However, there's also a 0.0015 paper capacitor that is attached onto the lugs, one of the 40 microfarads, and goes to negative. That one was apparently pretty bad because when I replaced it with the new one, it actually brought the B plus up quite a bit. However, because it's in an oddball location, I traced the wiring that runs to that lug, and it actually goes up and around here to this red wire, which attaches to this lug of the terminal. And since it's just grounds, it was easy to just place it here and get it out of the way. Plan right now is, I've actually revised this, instead of drilling out this rivet and getting this clamp out of here, I'm instead going to use one of the transformer screws. So underneath this can, actually right here, you can't see it, one of the screws, the innermost screw for the transformer, comes through. It's a self-tapper, but it's probably number 8-ish in size. So what we'll do is, once this is out and I've disconnected it, I will use a terminal lug, and I haven't quite decided whether I'm going to use these little 3-lug guys, center negative, with the 2 tabs, or if I'm going to use this big guy. My main reasoning is that if the clamp is still in place, this will come into contact, it'll be kind of close to it, and I am using axial lead capacitors, so they do take up a little bit more space than radial style. I don't have any radials rated at this. But either one of those will work, and I'll be using one of these in place of the selenium. So I'll use a 632 screw here, and I'll use a 632 screw to mount that. And I'll need to make sure to find 632 nuts that actually have a quarter drive head, because standard 632 are larger than what you normally see in these chassis, and in fact they'll be so big that they won't actually fit. They may not fit up here, they may or may not, and they might. But I like the look of the quarter drive ones because it means you can remove all the major hardware with the same screwdriver. I also replaced the 2 microfarad electrolytic that was over here. You can see our new guy doesn't take up a lot of room. Very clean. And basically every other paper cap except for this 0.05 right here is a 0.01. So very, very simple setup. So yeah, now it's time for a trip to the hardware store, grab a few things, and we should be able to finish this all up, and then we'll see about replacing this and calculating the right resistor. Well, we'll be less calculating, more just trying to find the right one, because I don't know how much current this thing draws, and since the selenium rectifier is obviously not functioning right, there's no way for me to power it up fully, and I also don't know if these caps are leaking. So once we eliminate all those possible faults, then we'll put it in a 1N4007 and start subbing and dropping resistors until we get where we want to be with a 125 volt output after the resistor. Alright, so after a trip to the hardware store and digging through a whole bunch of random parts that I have the Pilotuner reassembled. And it's not as pretty as I initially wanted it to be. Space issues came up. For one thing, this terminal strip right here was going to be one of the smaller 3-lug varieties, but I found that the wire coming from the power transformer wasn't long enough to make it to the smaller ones. It wouldn't have come all the way over to this lug. So I'm using this one simply because I had one, it fits, that's fine. So, for the power supply, we have a 1N4007 diode right here going between this terminal to here. I've got a jumper wire going over to our dropper resistor, which the Selenium rectifier has a greater drop across it than a silicon diode, which is about 0.5, 0.6 in the active region. And that goes over to our two new 40 microfarad capacitors. Center negative posts, I'm just using a 3-terminal guy, and I took one of the power transformer screws out, and we're using a 632 screw through that hole to mount it, which is working great. This 470 ohm resistor is tied back in. This is coming directly off of this power resistor for our first 40 microfarad, and then it loops back to our second shared negative, and that is actually tying back right here to this wire, which is the return on the power transformer secondary. I could have left that out actually, because both of these points are connected to chassis ground, but being that those are simply contact to this metal, I wanted to make sure that the most negative part of the transformer and these capacitors was directly hooked up. Nice solid connection. Got this 0.05 replaced. New 0.01 Y2 type safety capacitor from the switch to the chassis ground. The only cap I don't have a replacement for is the antenna capacitor back here. One of these little domino guys. I think it's 0.00015. It's like 15 picofarads or something. It's really tiny, and I don't have a Y-type capacitor that's small, so I'm leaving it alone for now. If you wanted to, I suppose you could just completely disconnect this white wire, which is what that goes to, or just cut the capacitor out and eliminate it, because you can use a 4-foot length of wire off of the terminal this goes to and just use that. That's what I was using for some earlier testing, actually, and it worked quite well. Yes, this does work, and we will show it off. The other thing was, I got really lucky with this value of resistor here. I'm using a 68 ohm. This is a 10 watt, which is overkill. I calculated that this set is drawing about 60 milliamps, 59.7-ish milliamps, when the power supply is at the 117 volt listed value they had in their table. At that point, we have almost exactly 125, 126 volts at this point here, which would be the direct output from the Selenium rectifier. Now, one thing that did not occur to me at the time that I was putting all these in there is that, being that the tubes are on a transformer, they do come up fairly quickly. However, since we have a diode instead of a vacuum tube rectifier in this, the B+ is going to come up immediately. So these capacitors here are rated at 160 volts DC. This is going to come up to about 126 at 117 volts. But on the original capacitor can, take a look here, these are rated at 150 volts, but notice they have WV. This is a working voltage, which means these are designed to operate at 150 volts all day long without problems. That's above what they're going to operate at normally, or what they would have operated at, but that means that the peak voltage that these can take is probably a bit higher, maybe 200? Something like that. On these common, probably Chinese or Japanese electrolytics, the voltage rating on there is not going to be working voltage. That 160 that these are labeled as is probably going to be the peak that they want to take, which I did not consider when I put them in here, because when this thing fires up, until the tubes actually fully warm up and start drawing current, the B+ in this thing is probably going to rise to a pretty good value. It could potentially get to 200 volts DC pretty easily on fire up, and over time that is going to wreak havoc on these capacitors. If I'm right, I'll do a quick check with my voltmeter. And additionally, That's at 117 volts. These days, 117 is very, very low. You're typically going to see 125 to 130 RMS coming out of the wall socket. So, yeah, I would recommend at least 200 volt or more, maybe 250 if you're going to do this. That's hindsight for me. But we're going to try it out, or I'm going to get the B plus rigged up here. So, that there. We're going to measure directly off of our 470 ohm. And I'm going to aim this over at our voltmeter. So this is on DC right now. And we'll see what we get. Now I am bringing this up on a Variac. Oop, actually, you know what? We're not going to cheat. If these blow up, they blow up. So, wow, that doesn't sound safe. You'd be right, it is not very safe, but I am doing this so other people don't screw up where I do. So, I am setting our Variac to 120 volts. It is plugged in, and yeah, let's see what happens. Alright, looks like we're peaking at 168. And we're dropping. Alright, so yeah, that is what I was afraid of. If we use this on modern line voltages, these capacitors are going to take a beating. One solution to this is that you can simply increase the value of this power resistor. I was using a 270 ohm 2 watt earlier and was getting about 100 volts output, and it seemed to work just fine with that. Honestly, that is up to the that's up to you. Now, I'm getting 133 with my Variac at 120 volts. If I back it off down to about stock input voltage, you can see that we're right at about where it was listed. Now, just because the manufacturer listed as 117 volts in the lab does not mean they maybe didn't account for higher or lower working voltages. Most manufacturers did. They're just saying that when they did the testing, that was the baseline that they used. However, as a margin of safety, you can, I would recommend upgrading the value of the capacitors, number one, or if you maybe don't have them, you could just drop in a higher value resistor and bring the B plus down. But the important thing is the peak. That initial surge voltage is going to cause all kinds of problems over time if you keep firing it up and subjecting them to this. So I'm either going to have to hook this up to a dropping supply every time I use it, or, which may be a better idea, would simply be swap these guys out with higher rated voltages. So when I decide to do my Howard FM tuner, I'm definitely going to order up some brand new Nishikons instead of just pulling whatever I had out of the stock and rebuilding it with that. But regardless of that, we know the B plus works, and yeah, I suppose I ought to hook this thing up and give her a listen, shouldn't I? Alright, so it's back in the cabinet, and we're ready for a good test. I was considering just using my standard computer speakers, but then I thought, oh, that's too lame and they won't sound good enough. So I have a better idea. We have a mono FM output. We need something with a monaural input.
Like, it's awesome if I can meet Mickey and all the rest of the cats, but like, yo man, I want to get on a ride. Right?
The Wish can't do a whole lot right now. The Sahara Desert by yourself.
Oh no, you can still make a wish.
It depends on your wish.
They just don't have the big fulfillment.
Cottonwood falling. That it's me they've been living.
Well, you have to remember, I'm a little bit older than you are. And being my age, it's hard to say this, but you have days when you would almost welcome death because you figure, well, you've been here.
Well, that's depressing, and I'm pretty sure I hit a whole bunch of copyright claims. But that's the Pilotuner. It is a fantastic little instrument if you just want something to play through your AM radios, or if you have an all mono tube amp and you want something to listen to besides mono LPs, I suppose. Thanks for watching, and we're working again on the GRU now here. I've got some more supplies for it. We'll be doing the alignment soon.